Hey guys, so for the past few weeks we have been working with finding area of different figures. The first week of school we reviewed finding area of squares and rectangles. The second week we moved into finding area of parallelograms and triangles, and last week we worked with trapezoids. So we're moving into the fourth week of school, and this week we're going to mix it all up. So this week you're going to see parallelograms, triangles, and trapezoids. I'm also going to introduce to you composite figures this week. Next week, or the fifth week of school, you're going to have to find area of composite figures, so I want to go ahead and kind of prep you for that. Make sure that you are taking notes, either using the guided notes that are provided on Canvas underneath the video, or that you are just taking your own notes in a notebook. Make sure you watch the video in its entirety, and if you need to watch it over and over again, that's totally fine. Stop, rewind, do whatever you need so that you get this material. Make sure that you reach out to me if you're still struggling with anything that you see today or that you've seen in the past couple of weeks. And here we go. Hey guys, so like I said, this week we are going to review finding area of parallelograms, trapezoids, and triangles, and then I'm going to introduce composite figures. So let's just review with parallelograms. We know that a parallelogram is a parallelogram because it has two sets of parallel lines. And remember, one set is going to be kind of slanted. So that means that you end up having two acute angles and two obtuse angles. Okay. The formula for finding area of a parallelogram is to multiply the base times the height. So A equals B times H. Sorry, that was the bell. So let's look at this practice one together. So we have a parallelogram here, and it has a base of 6 feet and a height of 3 feet. Okay. So we're going to do area equals base times height. Our base value is 6. Our height value is 3. 6 times 3 is 18. We always want to make sure that we include our unit of measure, which is feet, and since we're working with area, we have to square that. I'll give you a few seconds to write that down if you're taking notes. Okay, let's look at triangles. Identifying a triangle is usually easier for most. We know that a triangle only has 3 sides. There are different kinds of triangles, but it does not change how you find the area of that triangle. Remember, with a triangle, we have to do base times height divided by 2. And the reason that we divide by 2 is because a triangle is half of a rectangle. So we would find the area and then split it in half to only get the triangle value. So let's look at this example. Area equals base times height divided by 2. Our base value is 10. Our height is 8. And don't forget to divide by 2. 10 times 8 is 80. And 80 divided by 2, or half of 80, is 40. I'll give you a few seconds for those of you that are taking notes. Okay, now let's talk about trapezoids. So remember, trapezoids only have one set of parallel lines, and your set of parallel lines tell you what your 2 base values are. So in this particular one, our 2 bases are 8 and 7, and our height is 6. So to find area of a trapezoid, we have to add the bases, then multiply by the height and divide by 2. Okay? So our base values were 8 and 7. So we're going to add 8 plus 7, which gives us 15. Next, we have to multiply 15 times 6. Okay, and I did that over here. 6 times 5 is 30. And 6 times 1 is 6, plus 3 more is 9. So now we have 90 divided by 2. Some of you probably could do that in your head, but if you can't, I have worked it right here. 2 goes into 9 4 times. You bring down your 0. 2 goes into 10 5 times. So the area of this trapezoid is 45 inches squared. Remember, we always want to make sure and include our unit of measure and our squared. And I actually just realized that we did not do that on our triangle, so we need to jump back over here and fix that. That's my mistake. Okay? When I wrote it the first time, I did not include the centimeters squared, so make sure on your triangle notes that you added the centimeters squared. I'll give you a few seconds to finish taking notes on the trapezoids. Okay, now let's talk about composite figures. Composite figures are when you take multiple shapes or figures and you put them together to make a new figure. This week, we are just introducing composite figures, so you are not going to have to find the area of composite figures, but next week you will. So I want to make sure that we're prepping for that so that next week there's not like a shock. So let me show you an example of a composite figure. Okay, I want you to ask yourself, what smaller shapes do I see within this larger figure? So take a minute and just think about, if you could take this shape and break it apart, what smaller shapes could you break it into? Okay, I hope that you were able to visualize that there's a triangle right here. Okay. Now what's left is an L shape. When we're finding area, we don't have a formula for an L-shaped figure. We have a formula for finding area of a triangle, but not an L-shaped figure. So I want you to think about what we could do with this L shape so that we would have figures that we do know how to find area of. When I look at this figure, I see 2 rectangles. I see one larger rectangle here, and then I see a smaller rectangle right here. Now, next week, we'll take it one step further, and we'll actually take this figure and we'll break it apart, and we'll find the area of each smaller part. But this week, we're just going to focus on reviewing triangles, trapezoids, and parallelograms so that you're prepared for working with composite figures the following week.